That is where we are going to start today.
Any weekend plans, Mr. Brand?
I'm going down to Whitewater tomorrow because it's my daughter's 21st birthday. Hey, who sings that song?
I couldn't tell you.
Good, but let him anyway.
You said that for no reason.
I just did not know that. When we doing like a review, right? Everybody was just rushing. I was just taking my time trying to get the right answer. Yeah. 10,000 pounds. 10K. And some people only got like 1K or 3K.
And we're off and running, ladies and gentlemen. Okay, ladies and gentlemen, I don't have a question of the day for you today because what I'd like to do is get through the material today, get through a little bit on the lab, and then give you time to work on both. So with that in mind, I don't have a question of the day for you today. Your test will be next week, Tuesday, ladies and gentlemen. Okay? So when you're looking at our board up here, ladies and gentlemen, worksheet, 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 worksheet. Again, it would do you well to do them, especially this one and this one, because this is a lot of what's going to be on your test. But this is the one thing that's going to count towards your grade, and this is the one thing you got to get turned in by the end of the day today. So again, we're going to give you some time in class to work on it in a little bit, okay? The worksheet is going to be a way of practicing something that I'm going to show you in class today. So actually, what I think we're better off doing is I want to start with going over a few of the slides, the last few slides for the unit, because they're going to show you how to do one of the problems on your lab questions. Then we'll go to your lab questions. We'll show you again how to finish off your graph if you didn't finish yesterday and what to do with that, ladies and gentlemen. Okay? So that is the plan. So with that in mind, I'm going to go to the ESN and I'm going to go to slide number 39 in your notes. It's slide number 41 in mine, but I had those 2 extra slides the other day. That's why your numbers are off compared to mine. So slide 39 in your notes. So we did this idea of a half-life lab yesterday. And the idea of half-life is radioactive decay is predictable in how often it happens, but not predictable in which atom it will happen to. So yesterday you put a bunch of pennies in a box and you shook it. And then some of them flipped and some of them did not, right? You took out the ones that flipped, you left the ones that didn't flip in there, you counted them, it represented a half-life. Did we get exactly half every single time? No. But ultimately, by the time we got down to about 4 shakes, we were pretty close to having what we should have had left. A perfect shake was what was just about left. And that's what actually happens with radioactive decay. Over a long enough period of time, you will get about half of a sample left. Maybe not exactly, but very close. And it's very predictable, ladies and gentlemen, okay? So, one of the things, the definition of half-life is the amount of time it takes for 1/2 of a radioactive sample to decay away. That is what the definition is. The name pretty much says it all, half-life. Half of the life of the sample, okay? It can be measured in any unit of time, ladies and gentlemen. There are half-lives that go in under a second. There are others that go in tens of thousands of years. And this is why radioactivity is one of those things that is very dangerous, because it takes a long time for a radioactive sample to decay away and become something else. Okay? It takes a long time. So you could do seconds, you could do minutes, you could do hours, you could do days, you could do years. It all depends on what the sample is. Okay? There is always what is called a fraction remaining. So of the original sample, there's always a certain portion of it remaining. And after one half-life, it's 1/2. After 2 half-lives, it's 1/4. After 3 half-lives, it's 1/8. So it's a predictable amount, okay, as to how much will be left. It's the amount of sample left based on the number of half-lives something has been through. That is what fraction remaining is. Okay, so after 1 half-life, when you have 5 out of 10 grams, that's 1/2 remaining. Okay. Another thing that we will talk about is the number of half-lives. How many half-lives it's gone. Since that is a time, half-life is based on a certain amount of time. Okay, now you did it based on shakes. So 1 shake was a half-life, 2 shakes was a half-life. Well, if we wanted to make this more realistic, what we should have done is said, okay, we're going to shake it, we're going to take out all the pennies, and then 5 minutes later, we're going to shake it again. Take out all the pennies, 5 minutes later, shake it again. That would have been a half-life of 5 minutes. Every 5 minutes, some of the sample would have decayed away. Okay? And again, this is a very predictable thing, the number of half-lives. It's how many decays have happened based on time. Okay? So, we're going to do some very simple half-life calculations. Now, these could get very intense with math. Instead, I try to make them very simple for you. Okay? Fraction remaining can be determined by a formula. The formula is this. 1 divided by 2 raised to the power of n. Now, I know some of you are looking at that and going, Mr. Rand, that is not an easy formula. I agree with you. I'm going to show you an easier way to do this. But this is the actual formula. And that means 2 raised to some power, right? So after 1 half-life, n equals 1, that means 1 over 2 raised to 1. What is that? No. What is 2 to the first power?
2.
2. 1/2. What is 2 to the second power? 4. So 1/4 would remain. What is 2 to the third power? 1/8 would remain. It's a way of doing it. N equals the number of half-lives. I'll show you an easier way. Okay? The number of half-lives something has been through is the total time of decay divided by the time of each half-life. So in other words, if we know how long something has been decaying, and we know how long a half-life is, we can figure out how many half-lives it's been through. Remember yesterday when we were talking about francium? What was the half-life? Anybody remember? 22.5 minutes. Means we get through how many in class? About 3. Class is 70-some minutes long. That means you could fit 3 half-lives in there. Just be divided by 22.5 3 times, right? So that is a way of predicting how many half-lives somebody would go through, or the total time decaying, or the time of a half-life, if you were looking for that. And this, ladies and gentlemen, is what they'll use when they're talking about radioactive dating. Okay? They'll use a formula similar to this. Again, these are not the formulas, ladies and gentlemen, that I'm going to expect you to use. These are just formulas that you could use. Okay? The sample remaining, how much is there, is equal to the original amount, how much you began with, times the fraction remaining. So it allows you to say, okay, after a class period of francium decaying and it's been through 3 half-lives, how much would be remaining? Well, that would be 1/8. So if you know how much you had, you take that times 1/8, you know how much is left. Okay, again, I'll show you an easier way of doing it. So here's some examples of decays for you, ladies and gentlemen. And I do this to show you what we just talked about, which is time. Radon 222 undergoes alpha decay and it takes 3.8 days to do it. Francium, 22 minutes. Osmium, 2.0 times 10 to the 15th years. 10 to the 15th. Okay? That's over a billion. Okay? Very long time. 1.9 times 10 to the 19th. Even bigger number yet. Okay? For carbon-14, 5,700 years. That's what we use to date artifacts, how old they are. For potassium-40, 1.25 times 10 to the 9th years. Again, a longer period of time, ladies and gentlemen. Okay? Just to show you what they are. Lead, 210, 22.2 years. Bismuth, 207, 33.0. So all of these are different amounts, ladies and gentlemen. Down here, you've got one that's 153 seconds. That's about 2.5 minutes. You got one that's 8 days. You got one that's in years, another one that's in years. So again, half-lives, again, not expecting you to memorize these. Just showing you that they can be all different kinds of times. From things that are really short, in seconds, to things that are really long, in lots and lots of years. Questions? All right. So here is the way that we are going to do these problems, ladies and gentlemen. We are going to set up a table. Now, here's the nice part about the table, ladies and gentlemen. In the table, the math is a whole lot easier. A whole lot easier because in the table, you're going to do the same thing in each column every time. And here's what I mean. We're going to start out with the sample size. Somebody needs to pick me a sample size. Pick me a number of grams. 35. Okay. So we're going to pick a sample size of 35 grams. Perfect. So you can fill this slide in your notebook as we go along, ladies and gentlemen. Okay? You can fill it in. So we're doing 35 grams. That's what you want? Oops, sorry.
Yes.
All right. Excellent choice. Excellent choice. All right. I need somebody to pick an amount of time other than Ethan. He did a crappy job of picking the amount, so somebody else pick a time. You did fine. Don't everybody jump on it all at once. 120 what?
Hours.
120 hours. I like that. Got to put units with it. Now, we didn't have to put units with Ethan because we said it was grams. Okay? So here's the way this table starts out, ladies and gentlemen. Under sample size, I'm going to put that number that we just picked, 35. And up here, I'm going to write grams because then I don't have to put units by every number. Fair enough?
Yes.
Half-lives, we always start out with the number 0. Always. Why? Because you have the sample to begin with. It hasn't, and nothing has happened to it yet. Fair enough? Okay. Time, we're also going to start out with 0. Why? Because we're just beginning. So now we start our timer. We're going with 120 hours, as Kiana said. From 120 hours from right now, we'll be through a half-life. And the fraction remaining, we're going to start with 1 over 1, which equals how much? 1. But I want to write it as 1 over 1, and you'll see why in just a minute. Okay, ladies and gentlemen? Fair enough?
Yes.
Okay. So here's the thing. For this first column, all we are going to do is take this number and divide it by 2 each time and go down. So what is 35 divided by 2?
17.5.
What's 17.5 divided by 2? 8.75. What's 8.75 divided by 2?
4.37500.
I don't care about zeros.
Okay.
What's 4.375 divided by 2?
2.1875.
I'm going to round it to 2.188. Fair enough?
Yep.
Now, that is all you do to this column always, is take whatever number is there and divide it by 2 all the way down. Same thing in this column always. Whatever number you start with, you divide it by 2, then divide it by 2, then divide it by 2, then divide it by 2. Fair enough? Mm-hmm. Okay. Now the next column is even easier. Why? Because for half-lives, all we do is take the number above and add 1 to it. 1 plus 0? 1 plus 1?
2.
1 plus 2?
3.
1 plus 3?
4.
Now the reason I have this highlighted in blue, ladies and gentlemen, on every table you would ever do, this column looks exactly the same. It just counts down by 1. It just counts down by 1. Okay? All right. Now, for the time, we're going to start at 0 and we're going to add the half-life time. What's our half-life time? 120 what? Hours. So again, up here, ladies and gentlemen, just to save myself trouble, I'm going to write hours, because then I don't need to put it down below. And what was the time again? So I add 120 to 0. Then I add 120 to 120. What do I get?
240.
Then I add 120 to 240. What do I get?
360.
Then I add 120 again. What do I get?
480. If I got it.
Again, another easy column to do, right, ladies and gentlemen? All we're doing is adding the same number each time. Be careful, though. People will do 120, 240. What do you think the common mistake people make is when they go to the next one?
Hey, add the previous one.
What do you mean?
I got the 240 with it or something.
Well, they look at this and they go, okay, this doubled, so then they'll go 480, 960. Don't do that. This does not double. All this does is add the same number each time. Okay? Now, this is not going to be the same in every graph. Why? Because you're going to have a different half-life time. The same way this is not going to be the same every time, because it depends on what number you start out with. Fair enough? This last column, though, is also going to be the same every single time. Every single time, because it's the fraction remaining. And what we are going to do, ladies and gentlemen, the reason I wrote that as 1 over 1 is because you're going to take the bottom number in this fraction and you are going to multiply it by 2. So instead of 1 over 1, that becomes 1 over 2. And then 1 over
3.
No. 4. Multiplying the bottom number times 2. And then 1 over
6.
Come on. We're multiplying that bottom number by 2. 4 times 2 is 8. Then 1 over
16.
16. Okay? 1 over 16. So we've got to know which columns we add in, which columns we divide, and which columns we do some multiplication in. But here's the nice thing, ladies and gentlemen. This column will be the same in every table. This column will be the same in every table. Yes?
Does the numerator ever change?
In which one?
The fraction remaining.
No. The dot number stays the same because it's 1 out of 1, 1 out of 2, 1 out of 4, 1 out of 8, 1 out of 16. What's next? 1 over what?
1 over 32.
1 over 32. Then 1 over 64. The 1 on the top never changes. All we do is double the number on the bottom. Okay? Now, anybody got a calculator handy? Somebody, please. Pull one up on your computer. Okay? Do me a favor. Take 35 times 1 divided by 4.
8.75.
There you go. Take 35 times 1 divided by 8.
375.
Okay? So this fraction predicts how much of this is left. Because to start out, we had the whole sample. Then we have a half of it. Then we have a half of a half, which is a quarter. Then we have a half of a quarter, which is an eighth. Then we have a half of an eighth, which is a 16th. Those other formulas I showed you could work as well, but I think this is easier. I can divide by 2 very quickly. I can add 1 very quickly. I can add the same number fairly quickly. And I can take that bottom number and multiply it by 2 very quickly. Okay? Now, how much time has gone by after 3 half-lives here? What? Well, 3 half-lives, 360 hours. How much sample is remaining after 480 hours?
2.88.
2.188. How many half-lives have you been through after 480 hours?
4.
4. Everything is right here for you. Now it's just a matter of reading a chart. Okay? Now it's just a matter of reading a chart. Okay? So let's take a look at the next one real quick here, ladies and gentlemen. Let me clear this all off. Boom. Boom. All right. So here's our next question, ladies and gentlemen. A 650 gram sample of a radioactive isotope has a half-life of 2.5 hours. How long will it take to get to 40.63 grams of sample? Okay. Now those formulas I showed you are ways that we could do this, but to be honest, I don't like it. I don't like it. I don't like using those formulas. So let's do what we just did. Let's start with half-lives, ladies and gentlemen. What number always begins this column?
0,
And then what?
1.
3, 4.
Good. So that column's always easy, right? Okay, the fraction remaining is an easy column too. We start with 1 over 1. Then what? 1 over 4. 1 over 16. Perfect. 2 columns done. A matter of 30 seconds, not even, right? How much sample size did we have? 650 grams. I'm going to put the grams up here, right? Okay, so what do I do to that number right underneath it?
Divided by 2.
So what's half of 650? What's half of 325? Ooh, we got the easy one. This gets a little tougher.
162.5.
What's half of 162.5?
81.25.
What's half of 81.25?
40.625.
Okay. All right. So time, ladies and gentlemen. How long did it take to go through a half-life?
This bread. I can't read the last one.
Okay. I'm sorry. I realized afterwards that I have a crappy color on my slides. 40.63. Sorry about that. I noticed it was tough on my screen. I can't imagine what it was like looking at it from your view. So for time, we start out with 0, right? What's the first number? 2.5. What unit is it? Okay, just so that we're clear. What's the next number? Nope.
5.
Point.
0.
Good. What's the next number?
10.0.
No. There you go. There's the mistake we said people were going to make. 2.5 to 5. Oh, well, we double this then too. What is it?
7.5.
7.5. Then what?
Now it's 10.0.
Now it's 10.0. Okay. Originally, they asked us to find how long it would take to get to 40.63. Here's 40.63, right? How long did it take to get there?
10 hours.
Yeah, 10 hours. How many half-lives have we been through?
4.
All the information is right there in front of you, ladies and gentlemen. All of the information is right there in front of you.
So for the fraction and the half-life, we could fill that in for all the columns.
Yeah, it's the same every single time. Now, don't get me wrong. You're doing the same thing here every time, which is dividing by 2.
Mm-hmm.
But I don't know how much they're going to give you. Okay? By the way, what if they gave you an amount down here? They said after 4 half-lives, there was so many grams remaining.
You can times it by 2
To do what?
to get the one above that.
To go back up in this table, if you were given a number down here to start, to go back up, you would simply multiply by 2, right? Right? Okay? So again, good catch. If they give you a number somewhere down in the table and they're asking you about this, all we do is multiply it by 2 to go up. If we're dividing to go down, we multiply to go up, correct? Okay? So again, you know, that's the kind of stuff you'll be asked to do. Questions?
No.
All right. There is more practice on this on the worksheet, but what I now want to do is I want to go back to our lab because I want to make sure we have time for you to get your lab done. Okay? So, please open your lab, the document, and the Google Sheet for your lab. Ethan, I put an alternate assignment in for you. The data is in there for you. You can work with your data for this lab. Okay? All right, ladies and gentlemen. So, sorry. All right. You guys filled in these numbers yesterday. You do not have to fill in all these numbers in the Google Sheet. Okay? You do not. We had you do this. We had you collect it together. You do not need to put all this in there. Okay? But what I did do, ladies and gentlemen, is this. In your lab now, this is your lab. Let me get this out of the way. In your lab, this is what the last column of your table should look like for every single person in here. Every single person, this is what your last column should look like. So if you open up your lab and it does not have these numbers in there because you didn't copy them yesterday, you need to put them in there. Now, you should have filled in these numbers yesterday when you actually did the lab, correct? And then we told you to take these numbers and put them in the Google Sheet, and then you got these numbers, correct? Okay. So, Ethan, you weren't here yesterday. That's what you're going to have to do is take these numbers here, copy and paste them into the Google Sheet, and I'll show you where to do that. So, in the Google Sheet, ladies and gentlemen, you go into the one that says average data, okay? Now, if you copied and pasted your numbers into here, ladies and gentlemen, it gave you these automatically. It did the math for you. You just need to take these and put them back into your original lab document in here, okay? And then that will complete this table for you. Questions on that? And please ask if you got any because this is part of the lab that easy to get points on, but also easy to lose it on. Any questions at all?
Does Hyzium have a unit?
That is the unit, the number of Hyziums. That is the unit, okay? Since we counted things, we didn't actually measure them, our unit is going to be the number of. The same way with half-lives. Our unit is the number of half-lives because we counted them. We shook it once, we shook it twice, we shook it 3 times, okay? So once you have this table completely filled in, you should also have this table completely filled in, ladies and gentlemen. Now, when you have this table completely filled in, down at the bottom, if you go to Lab Graph, it will have automatically graphed your data for you. 2 lines on here. Go.
For the labels, what are we supposed to do?
That's what I'm getting to. That's what I'm getting to. So just hang on a second. Thank you, though. Okay? You should have 2 lines on your graph. One is your average data, the blue line. The other is the class average data, the orange line. Okay? Questions? Okay, good. Now, for labels. Zoe, you wanted me to do labels, but now you're doing something else, so stay with me here. Okay? What is 0, 1, 2, 3, and 4? The number of half-lives. Now, multiple ways to get down there to fix this. You can literally go right on where it says labels and double click it. And it will allow you to get in there, and it will allow you to type directly in that box. But it also puts it over here on the side. So if you were to do edit chart, customize, chart axis and titles is one of your options. And then you can do the horizontal axis. Does anyone need help getting here? Okay, so what do we type in here?
Number of half-lives.
Number of half-lives. I'm going to type in here, change this, please. Okay? So you're going to, don't type in change this, please. Type in number of half-lives. Okay? Now, on the y-axis, by the way, I could either go over and click on it like I did, double click on it, or I can go here and I can click vertical axis and I can highlight it in the text title box. Okay? What do 0, 20, 40, 60, and 80 represent? The number of headsiums. Change this as well. Okay? So the number of headsiums would be my choice. One last title to change, and that is the one at the top. Okay? Now, I'm going to give you a couple of options here. You can do what is on the x-axis versus what is on the y. That is the way we have been doing them all year long. Or if you want to change the title to something like half-life decay, nuclear decay, radioactive decay, your choice completely. But again, remember, change this title. And don't tell me you changed it to title. I will not accept that. Okay? Now, as always, ladies and gentlemen, there are ways over here down at the bottom that you can make the graph more yours. You could change fonts, you could change colors, you could change size, things like that. You can put it on the left-hand side, in the middle, on the right-hand side. You're welcome to do whatever you want to make it your graph. Questions? Okay. Now, ladies and gentlemen, now we're going to take and we're going to put it into our lab. Okay? So in our lab, we are going to get our cursor so that it is just below where it says insert the graph from the data sheets and make sure the axes have labels and units and that your graph has a title. Now, again, ladies and gentlemen, there would be absolutely nothing wrong with you hitting copy chart here, going into this and hitting control paste. But I do not like the way that graph looks when you do it. I just don't. It bothers me. So I'm going to do it another way. I'm going to do insert chart from sheets. So insert chart. Whoops. Sorry. Not what I wanted. Insert chart from sheets. Now, for you guys, ladies and gentlemen, it will be right there for you. It should be the top one in the upper left-hand corner. That should be yours. Whoops. Insert chart from sheets. Okay. Now, when you click on it, it should bring up a picture of your graph. If that's the right one, click on it and hit import. And there you go, you're done. Okay? Yes.
So we're not gonna like change the title for this one?
Yes, you should have. Again, you could put it as nuclear decay, radioactive decay. You could say number of half-lives versus number of heads, however you want to do it. Okay? And by the way, if you bring it in this way, and then you realize that you want to change something. I did not like that title. Okay, I change it. I click off of it. I come here, look at the button here. It says, okay, update. I did not like that title. It changes it for you. You don't have to re-put the graph back in because you changed something. You can simply update it. Questions? What's that, Zoe?
I'm trying to insert the graph here.
Do you need help, Zoe?
Yes.
Okay. So, up to insert chart. Go across. Nope, you got to stay on chart until you make it across, and I'll go from sheets. Go to reset. Click on that. Click on it again. Double click on it. Okay, hang on, there it is. Now click on that. You got to click on it. Now that it's highlighted, hit import. There you go. All right, anyone need assistance with this?
Would you accept that for the title?
Yeah, sure. Questions? Christian, you need a hand? There you go. Okay, so on that axis, that's the number of heads. Yep, that's what we called it, number of heads. Okay. Questions, ladies and gentlemen? Other questions? Okay, so let's take a couple minutes then, ladies and gentlemen, and let's look at the questions that I ask you. Okay. Describe the appearance of your two graph lines. Here's what I mean. Are they straight or curved? And do they represent an inverse or a direct relationship? You have to answer. Now, again, you could say both are this and both are that, but you need to tell me for sure about both lines, and you need to tell me if they are straight or curved, inverse or direct. So you got don't just say they're both this. They're straight or curved, they're inverse or direct. Answer that question, ladies and gentlemen. Should not be that difficult for you. We beat the heck out of this during the gas law unit. Okay. Ladies and gentlemen, here is the thing. Right now, you're getting a chance to do this. That means that before you leave class today, you should be able to turn in this lab. So if you have questions, if there's something you don't understand, now is your chance to ask, because I am right here. If you don't do this and then you go home and you're like, I'll just do it after school, and then you get home and you're like, oh, I don't remember what he said about this. That's on you. Okay? That's on you. That's fine. Inverse and direct describe the direction. Curved and straight are a different relationship. So remember, an inverse and a direct relationship describe the way that the line is going, the direction of the line. One is up and one is down. So now you got to think, which one is which? When it's going up, is that inverse or direct? When it's going down, is that inverse or direct? Okay? All right. Now please listen, because for number 2, you get to decide on an answer, and as long as you justify your decision with why you did it and it makes sense, I will give you credit. But let me explain what I mean by the question. Which set of data, your own or the class average data, provide a more convincing demonstration of the notion of half-life? Now, you each have your own class average or your own average data. We all have the same class average. So for a second here, I want to go back to this table. Okay? So what we are looking at, ladies and gentlemen, is we are looking at this column here, your numbers here, the numbers here, and what I want you to compare them to are these numbers that I'm about to write down. Don't write them, but this is what you're going to compare them to. If it were a perfect set and we started out with 80, how many would we get when we did half-life? What would be the amount left after one shake? 40. What would be the amount left after 2 shakes? 20. What would be the amount after 3? 10. And after 4? This would be what we call a perfect set. If we got half-life exactly as we are supposed to, this is what should happen to the numbers. Now, is it what happened here? No. Even our all-class average, it didn't happen there, right? But what you're going to look at is your numbers here and these numbers here and say, all right, which set is actually closer to this? Now, how you justify which is closer, that's the part where you get to explain why you think this data was closer to this than this one was. Okay? So you get to pick either one of these, and as long as you give me decent justifications, you could say either one. But if you look here, ladies and gentlemen, these are pretty darn what? Close. But also, how many of them are absolutely correct?
1.
Only 1. So maybe your data, your set, well, the first number wasn't that great. Maybe the last 2 numbers were right where they were supposed to be. So maybe you're going to say your data is better because 2 of the 4 data were exactly where they were supposed to be. That's what I mean by you get to decide which one you think is closest and give me the reason why you picked the one you did. So take a minute and answer that question, ladies and gentlemen. A lot of questions in science, ladies and gentlemen, are up to your interpretation. And a teacher cannot, or at least I will not mark them wrong if you give me reasoning as to why you picked the one you did, and it is sound reasoning. Okay? So again, I'm not telling you which one to pick, But I am telling you, you should have a reason for picking it, and it should make sense. Okay, ladies and gentlemen. Number 3 is doing the table that we were just practicing at the start of class. Now, I have blocked out the time because for our lab, we didn't have an actual time of a half-life. Like I said, if we had said, okay, after 5 minutes, shake your box, we would have had a half-life time, but we didn't do that. Please remember, this column, same on everyone. Same on everyone. What do we do with this number here each time?
Divided by 2.
Divided by 2. And what happens here? Add what?
1.
Add 1. So when you complete this table, though, do not forget to go back and answer the question. So you need to complete the table and then go back and answer the questions. How many undecayed hexium nuclei would remain out of the sample of 6,000 after 4 half-lives? So find where 4 half-lives is, find how much would be remaining, ladies and gentlemen.
Can we highlight it?
No, you answer it in the box down below. There is another box down below there. So in that box, you tell me there would be this many left after 4 half-lives. In this box down here. Do not highlight it. Do not expect me to go find the number. In that box, you tell me how many remain.
Oh. 350. I got 375.
Oh my god, I want to kill someone.
Actually, won't let me. Bro. My answers are so hard. From the last 2 questions.
Okay. Please listen, even if you are not done with that question. Please listen. We're going to go through these last 2, and then I'm going to give you time to get things finished. to work on the worksheet on half-lives and to turn these things in. Okay? So this is my last part. I'm going to talk about question 4 and 5. Here's what I will tell you about question 4. There are two exact opposite answers, both of which will be acceptable depending on the reasoning you use behind it. So let me explain. Assuming that we begin with a large amount of a sample, after a half-life, you always lose half of the sample. That's what you always lose, is half. This quickly causes the amount of sample to drop. But will you ever actually run out of sample if you have enough half-lives? So, you get to decide, yes, you will run out of sample, or no, you will not, and you need to justify why you are saying that. Now think about it, ladies and gentlemen. The term half-life means how much goes away. Half. Half of a lot or half of a little. Still, only half goes away. But now, think about your lab. After 4 half-lives, how many pennies did you have left? And if you shook them and shook them and shook them 4 more times, how many would you have left? And you can justify either one of those answers. Now, the next part, number 5, in this simulation, is there a way to predict when a particular penny would decay? So you took one of your 80 pennies and you marked it with a red marker and you put it in there. Is there a way that you could say, you know what, on the 3rd shake, that one's going to flip? That's what this question's asking you. Could you predict when that one penny would flip over? Not all of the pennies, just that one penny. Is there a way to predict when it will decay, when it will flip? Again, probably acceptable to say yes or no as long as you justify with some decent reasoning. Questions? Okay, you have everything you need to get your lab finished, ladies and gentlemen. If you need help with something, if you have a question, you can call me over. I will clarify things even more for you. But if not, ladies and gentlemen, you have got about 16, 18 minutes left to get the lab done and turned in. And then if you do, to start looking at the half-life worksheet. Go to work, ladies and gentlemen. And if you have questions, please, please, please